As we'll see, RIP redistribution, or redistribution into RIP, I should say, is just about as simple as everything else we do with RIP. The network command, version 1 or 2, no auto summary, but there's one detail, this seed metric, that we really have to watch out for. And that goes for production networks as well, because when we're on the pod in a moment, you'll see that the router really doesn't give you a warning when you leave the seed metric out, but you're also not going to get the results you want either. The config I'm showing you right now in the guide is simply redistributing static routes into RIP. And you can see that iOS help shows us that we have the metric option, we have the route map option, more about both of those later, and then we have carriage return. And when we see that, what we tend to think, especially after the months and years of study to this point, is that, yeah, I might need some options after this basic command, but this command will give me what I need. Well, it's a little bit misleading here, because while the command redistribute static is certainly a complete command, it's not enough to do the job when you're redistributing routes into RIP. We have to plant a seed. That's a great way to remember it, because it's the seed metric that we're looking at. The basic problem with RIP comes back to that hop count. And we know what that is. The maximum is 16. If RIP sees a route with a metric of 16, it says, oh, that's unreachable. Well, OSPF metrics are going to be a lot larger than 16, so are EIGRP metrics for that matter. If we take an OSPF route with a very simple, relatively low cost of 74, that would be one serial interface plus one Ethernet interface, even sending that route over to RIP is going to cause havoc. RIP is going to have a nervous breakdown because it's going to say, hey, I consider a metric of 16 to be unreachable, and you're giving me something with a metric of 74. You know, that's 5 times infinity times unreachable. I don't know what to do with that, so I'm not taking it. And that's what will end up happening. What we have to do is tell RIP, hey, we understand. Here's a value for the route that you will understand, and it's a starter route or a seed metric. And what we do in the RIP config is tell RIP, okay, every route that's coming in from OSPF has a metric of 2. And you can set that seed metric from 0 to 16, as you'll see in a moment. But I would warn you against doing anything in double digits with a seed metric, because then already you're kind of limiting how far into the RIP domain you're going to be able to advertise it. So I generally go with 2 unless I have an overwhelming reason not to. Now that seed metric, again, it's going to increment as the route goes through the new domain. So again, you might not want to start with a double digit seed metric, because then you can't send that particular route very far into the RIP domain. The lab I've set up is this. I've got a RIP domain and an OSPF domain. The RIP domain is between routers 1 and 2 over the 2110 network. I have a separate circuit between routers 1 and 3, the directly connected network we've used quite often, 172.12.13.0. That's an OSPF domain. Router 3 is also connected to the 172.12.34.0 network, and it's advertising that route into OSPF. And what we would like is for router 2 to be able to see that. So let's go ahead and bring the pod up. But before we do that, let me ask you one question here. And I've already checked all the connectivity and the basics that you would do in a lab environment. But in an exam question, in a job interview, in a production network, before you even started configuring this, what would you make sure of on the border router? And that's the big clue, because that's where the action's happening, right? That's where the redistribution is actually going to take place. You better make sure that your border router has the route or routes that you want to redistribute in the first place. And I know, especially the first time, if this is the first time you've heard me say that, it's like, you're kidding, right? I mean, why would I not do that? Well, it's easy to miss that if, say, you have 50 routes here and you want to redistribute 30 of them, but you only have 29 of the 30 that you need on router 1. Well, then you perform the redistribution and you end up troubleshooting your redistribution from 1 to 2 here, from OSPF to RIP, and the entire problem all the time was the border router didn't have the routes. So yes, I understand that's kind of laughable when you talk about a one route lab, which is what we're doing here. But when you've got a lot of routes and you want certain ones to be redistributed and certain ones not to be redistributed, and we'll talk about how to do that later in this section, you better make sure your board or router has the routes that you think it has first. And I do mention that here in the guide. And again, when you perform route redistribution, especially if you see some of the routes but not all of them, then that's the first thing I check. Does the board or router have the routes that I think it has? So let's skip back up here to this diagram, and we're going to redistribute the OSPF routes into RIP without setting a seed metric. Now, if I'm doing that, do I go into the RIP config or do I go into the OSPF config? I'm taking OSPF routes and putting them into RIP. You always config the protocol that is receiving the routes. Watch that, it's good detail. So redistribute is actually a legal command on its own. But you'll also see a lot of our old friends here and some new ones. BGP's here, there's EIGRP, IGRP is still on this one, metric for redistributed routes, OSPF, RIP, etc. So we're going to go with OSPF. Now that will not be enough, because anytime you redistribute OSPF routes into another protocol, you've got to specify the process, the number of the process. Good thing to watch out for too on an exam question, I would think. And we've got some options here. And the bottom one tells us that this is by itself a legal command. So let's go ahead and hit enter. We're taking the OSPF routes, putting them into RIP, so we'll go to router 2. And what do we see here? We've got the loop back from another lab, that's no problem, and it's got its other directly connected segment, but there are no other routes. I did a debug, not a debug, but a show IP route RIP to begin with, and we didn't get anything. But we also know that RIP is dog slow when it comes to convergence, right? I mean, it's really, really slow, and by that I realize I'm insulting dogs, which I don't mean to do. I love dogs. So let's do a clear IP route asterisk. I want to remind you of this command too. This clears your routing table of all dynamically learned routes. What you're basically doing is forcing an update of your dynamic routing protocols. If you are running a protocol with adjacencies, say EIGRP or OSPF, this does not tear the adjacencies down. So let's go, actually let's stick on router 2 for a moment. And we're still not getting anything. And we're not going to get anything for a long time, and we know why, because we did not put a seed metric in for RIP on router 1. We have two different ways to do that. I'm going to show you both of them. And the first one actually is the more common of the two. And it also lets me give you a little dad lecture. Hold on. Let's bring that. I know you're saying, oh yeah, boy. What you always want to do before you put another redistribute command on to replace one is get rid of the one that you're replacing. Because if I put redistribute OSPF1 metric 2 here, that is not going to overwrite that redistribute command. And when you have two redistribute commands from the same process, things can get a little squirrely. So you don't want to do that. Just go ahead and do a Control A to go to the front and just remove it. Now we're going to put it on there in the correct manner, specifying a metric. So I'm going to use the word metric right here. And there's the values I was telling you about, 0 through 16, default metric. So I'm going to set a metric of 2. And we'll go ahead and do a save. By the time I get over to router 2, I bet those routes are there. Actually, there's one more thing I want to do though on router 1. Before we do that, I'll let the route save. I'm going to redistribute my connected routes on router 1 as well. Because that 172.12.13 network, I want router 2 to see that as well. But that's not an OSPF discovered network on router 1. That's a directly connected network. So, whoops, that almost caught me. Router RIP. And actually what you can do is just repeat that command and just put static in for OSPF1. Or, excuse me, connected. So let's go over to router 2 now and see what we see. And there they both are. There is the OSPF route we redistributed in, 34, and the directly connected network from router 1, 12.13.0. Notice the AD and RIP does not change. There's no other routing code. You know, we know that with EIGRP routes and OSPF routes learned via redistribution that the codes are going to be different, but with RIP it's just same old RIP, same old R and same old AD of 120. I show you all this in the study guide as well. There's that troubleshooting option that I wanted you to know about. I show you the clear IP route command. I did run a debug here. That's another good command. Just a quick reminder, debug IP RIP. And that, of course, is going to show you the content of the RIP updates that are coming in. And in this case, you know, we weren't getting any, we weren't seeing them. Then I took those first two redistribute commands off and replaced them with those two redistribute commands, and we're in good shape. So we see what the routing table looks like. But what happens now if we try to ping router 3? You know, can we ping 172.12.34.3 right now? It doesn't look good. Once you see that second dot, you're kind of in trouble. So we're trying to ping 12.34.3, router 3's Ethernet 0 interface, and we can't do it. I show you the traceroute command in the book. I want to show you something else I like to do in this situation, because it is an oddity. We can see the network, but we can't ping it. And I do that on purpose to remind you of a really important concept here. We'll review that in a moment. What I also like to do is start at router 2 and say, okay, can I ping router 3's serial interface here? Can I ping 13.3? If I can't do that, can I ping 13.1? If I can't do that, can I even ping .1 on my own subnet? I like to work backwards that way because that gives you an idea of where the issue is. Because this is something I mentioned in the CCNA class. Ping is fantastic for what it is. It tells you that you have a problem. But the larger your network gets, the less obvious the problem is going to be. And you can't just say, okay, well, I can't get from 2 to 3. Well, where's the problem? Is the problem actually on router 3? Is the problem actually on router 1? You know, what's going on? We have to be able to spot the issue, and the larger the network, the more challenging that is, and we can't just rely on ping to show us how to do that. So instead, what I'm going to run is traceroute. And I'm simply going to put in 172.12.34.3. I'm going to get something there pretty quick, but not a whole lot. And the problem at this point is that I better know what that escape sequence is, or I'm going to be looking at 30 rows of asterisks. And you know what's really bad? When somebody behind you, you know, they're looking over your shoulder at this, and they'll wait till about row 16, and you're sitting there thinking, man, is this ever going to end? And they finally ask you something like, is it supposed to be doing that? You know, and then you can either say yes or no. But you need to know how to stop that. And just like I just did, it's Control-Shift-6 twice. That's all there is to it. So the pings, you know, you can generally let those run out if there are only 5 of them if you're using a regular ping. But again, with traceroute, once you start getting these asterisks, that means your traces aren't going any further than this, and you're going to end up getting 29 rows of asterisks in this case, so you better know how to stop that. So what I'm going to do right here is stop the taping for a moment, and on the next video, we're going to finish troubleshooting this, and then we're going to get into some important OSPF redistribution defaults. So I'll see you over on the next video.